Hi friends, welcome to my channel. In this video I'm going to discuss about level measurement using conductive probe. This is basically a discrete process measurement. If you see, the process measurement can be classified as analog or discrete. Discrete will gives a continuous information. If you see the level measurement by using analog measurement technique, so it gives level information each and at each and every point inside the tank. Whereas discrete information means is yes or no, whether the tank is full, whether the tank is empty. If you need only that type of information, you can use discrete process measurement techniques. In this video, I'm going to discuss about this discrete level measurement by using conductive probes along with this inductive relay of make BW controls. So before going into this measurement technique, so we'll discuss the working principle of the transformer. The transformer will consist of two windings, primary winding, secondary winding and core. This is the E1 voltage that is applied to the primary side. This is the uh, number of primary winding turns N1. N2 is the number of secondary winding turns. This is E2 voltage, and I2 is the current that is passing through the secondary winding. So E2 is given by N2 by N1 into E1. E2 is also given by I2 into R, where R is the impedance of the secondary winding. So how this level measurement works, we'll see. These are the probes that are being used for level measurement technique, and these are inserted into the tank where your level need to be measured. And these probes are connected to the secondary of this inductive relay. This is the primary winding or primary coil, and this is the secondary winding or secondary coil you can call. And this is the armature and to which the contacts are connected. So basically here if you see, it's an NO contact. So whenever this relay is activated, that time this NO contact will become NC like this. If you are having NC contact for this relay, so whenever it is in not activated condition, so in that case, so this NC contact will become NO whenever this relay is activated. So depending upon the user requirement, the type of contact need to be selected for your relay. So how this inductive relay is used for controlling the liquid level inside the tank, here we'll see. So this is the primary winding to which voltage is applied. So whenever the liquid level is not reached, means we have connected these probes in such a way that these probes are in open condition, means there is an high resistance part between these two. What will happen, whatever magnetic field that is being generated is confined to this location. Because of that, so this armature will not change the contact, it will be NO only. So whenever these probes see the liquid, what will happen, they create a low resistance path like this. Because of that, so what will happen, this secondary winding will generate a opposing magnetic field to this primary winding. Because of that, some of the magnetic flux goes towards this side. Because of that, what will happen, this armature will be attracted upside, and this contact will change its position. So earlier it is NO, now it will become NC. You can use this contact for turning on or off the pump. So this is as per the requirement you have to use. Here you can see this equation we have discussed, and this is the magnetomotive force. This is the force that is attracting the armature, that is given by N2 into I2. And if you see, if you derive, it is given by N2 square into E1 by N1 into R, where R is the impedance of the secondary winding. And if you see, for high conductive fluids where the resistance will be low, in that case for generating the same magnetomotive force, so you can use less number of N2 turns. For low conductive fluids like DVM water, demineralized water or distilled water, where the resistance is very high, so for generating the same magnetomotive force, you need to use more number of N2 turns. This is how. So depending upon your application, your fluid requirement, you need to select the inductive relay according to the number of the turns. Suppose if you are using for high conductive fluids like metal powders, so the inductive relay with less number of turns can be selected. And if you are using this relay for DM water or distilled water, which is having very high resistance, in that case you need to select a relay which is having more number of secondary turns. So if you see the specifications of this inductive relay, the primary voltage generally can be selected based upon your control system voltage. If it is using 230 or 120, whatever voltage your control system like PLC or relay control system is using, same voltage can be connected to this primary coil. Accordingly, you can select your primary coil voltage of your inductive relay. And the secondary coil voltage generally depends upon the type of the fluid. So your level measurement is being measured. Suppose if you are using for metallic powders where the conductivity is very high, in that case you can go for low number of turns because the coil voltage requirement is very less. And if you are using it for DM water or distilled water, so you can select the coil voltage of higher voltage because it is using more number of secondary turns. This is the one application so that I will discuss here, which is used for pump up control. Means whenever the tank level goes low, the pump should turn on. Whenever the tank level reaches this position, this is the position, that time the pump should stop. So how this relay is connected for this application, we'll see. So this is a well pump. So this relay is connected to this well pump. So depending upon these probes, so these conductive probes which are inside the surface tank, storage tank, so this based on this level you are controlling this pump. Here if you see, the primary coil winding is given by 3 and 4 terminal. So this is the 3 and this is the 4. And secondary coil terminals are given by 8 and 7. And 7 is connected to one NO contact which is given by 9, and another side is connected to 10 which is grounded, and this is also connected to common electrode. And 8 is connected, if you see, this is connected to start electrode, and 7 is connected to stop electrode. And one more contact is NC contact. Here you can see this is 5 and 6, so that is connected to pump. So whenever this relay is not actuated, that time if you see it is NC, means that time voltage B is being applied to this pump, that time pump is on. So whenever this becomes NO, when this will become NO, whenever this relay is activated, that time it will become NO, that time pump is off. We'll see how this is being done. So first case you consider that as tank is full, means all these electrodes are immersed in the fluid which your level is being measured. So what will happen in that case? So 8 is connected to 7, it is connected to 7, and also 7 is connected to 9. This is the case because all three electrodes are coming into contact with the liquid. So here it is creating low resistance part between the secondary coil. Because of that it is being actuated. So whenever the tank level is full, this relay is activated, and because of that what will happen, this will become open, so the pump will be stopped. So when the pump will be started again, so here if you see, even though the level comes here, the pump is still not started. So here if you see, this stop, here if you see, this is an NO contact. So whenever this relay is activated, this NO contact will become NC, so this will be closed. So the 7 is being disconnected because this level has come here, so 7 is not in the path. So 8 and 10 are in the path. Here you can see start electrode is and stop electrode also are then coming into contact whenever the level is here. Okay, so still the pump is not started because this secondary side there is still a closed path. So because of that this inductive relay is activated. So once the level reaches here below this start pump electrode, what will happen? So this will be disconnected from the path. So once this is disconnected, what will happen? There is no conductive path between these secondary coil terminals. Because of that the relay will be deactivated. Again this will be closed, it will become NC, because normal whenever it is deactivated this will become NC. Then the pump is again turned on. So this is how the level inside this storage tank is maintained by using these three electrodes. And this pump which is being controlled is a well pump which is below the ground. This is a pump up control, means whenever the tank level is high, so the pump need to be stopped. Whenever tank level goes low, the pump need to be started. So one more application is this pump down control, means suppose if you are using some seawage tanks where whenever the tank level goes high, that time you need to turn on the pump. Whenever tank level goes low, the pump need to be stopped. This is opposite to pump up control. In that case, so you can see the same relay can be used. So here, so whenever the tank level, this is, you consider this as a first case. Whenever the level has reached high, both these probes are coming into contact. Because of that, what will happen? These two, this is the secondary coil, so it is creating a short circuit between these two, because here it is a short circuit or low resistance path or even low impedance path, you can treat like that. So because of that this relay is activated. Once this is activated, here you can see this is basically a normally open contact, it has become NC. So once it NC, so this contact has been closed. So once the level goes below, so the start electrode, still this relay sees a low resistance path because here there is one more NO contact. This is still closed. So even though this is being disconnected, because it is getting a low resistance path through this. So because of that this will be still in this secondary coil will have a low resistance path. So because of that the relay is activated. Once the level goes below this pump electrode, that time what will happen? Both this and this both are disconnected. Because of that the secondary coil doesn't see any low impedance path, and then it will the relay will be deactivated. Once it gets deactivated, here you can see this will become NO and also this will become NO. So no voltage is applied to the pump or pump motor starter. Thank you for watching my video.